Yeah, so this point is also important in terms of your design, because you are going to design the aircraft based on the applications and then customer. That customer can be for the civil applications like civilians, or maybe for commercial purpose, especially some agency. Uh, Either you have oil related, or maybe different company, they are looking now to use this type of smaller UAV, not bigger aircrafts. But especially if you're talking about the bigger aircrafts, mostly will be related to defense, correct? Either air force or navy, or maybe the army related. So of course they require the launching platform recovery. So if you have air force, maybe landing, you have runway requirement for that, either for launching or the recovery itself, or maybe parachute. Okay, so those things are there. But naval side, you have INS platform, those things is there, and maybe net recovery possible. So either use the runway again as a INS platform, but very tough, because INS attitude, or the INS platform attitude should match with the aircraft attitude during the landing, correct? Fixed runway, normally on the ground, you never care the attitude of the runway, correct? Attitude mostly will be constant. Only aircraft attitude should align with the ground, correct? But in the INS platform, we never think like that. INS platform attitude, either fight, theta, psi, if you check all, going to be changed, correct, based on the motion in this inside. So if you look that, then you have to check what the attitude of the aircrafts, and then they should monitor once synchronized matching. Okay, then only going to land. Many times, like if you're going to see one or two maybe crashes happened, where main rotor blade of their helicopters hit it to the, I think, boundary of the platform, this type of INS platform. Okay, so you can check those things also. What are the issues when recovery the aircraft, either a helicopter's fixed wing, any type of this type of aircraft on that type of platform. So this is very important when we talk about the designs. What is the how we're going to launch this, and how we're going to recover the aircrafts. Okay, so this is also a very important point here. Overall systems, of course we are talking about the complete setup here. So if we are looking like a launch related one point, like you use the either wheeled aircraft which require the normal runway, and if a ramp launching the aircraft with various alternative missions, so you need something to what's called this should be vehicles, correct? So like you're launching that, and then VTOL type of, or maybe if you have different aircrafts like helicopters, those things, then of course totally different. So VTOL operations not only constant for the helicopter, this can be your fixed wing with the multi-rotors type of the aircrafts, correct? Which now you have seen what are the trend today, correct? So most of time long back VTOL means the helicopters, today VTOL means both, correct? Is it a helicopters or your aircraft which has that VTOL capacity? So under the overall system, they analyze all. If depends what type of your launching or recovery type of requirement is there. So if runway length requirement, then of course you need minimum speed, correct? Minimum speed for generating the lift. So how long runway require for getting that speed? So that is also important. When they are going to land also, they should have minimum speed, correct? It's not like a decrease further. So of course they should have at least minimum speed to let's have a lift to sustain the aircraft in the air, correct? Then that speed should reduce further uh, when touching the ground, correct? Means you should have enough runway require after TDP. Okay, so this all activities depends on the what is called either you have takeoff speed or maybe landing speed. They take care what is the runway require. The size, power, and sophistication of the launchers is also important when you are talking the different, not like runway, but if launcher, then what is the minimum speed of the aircraft should be there, okay, and what is the maximum speed of the aircraft require. So your launcher should support that much, okay. If minimum speed required during takeoff. So your launcher at least gives minimum speed to the aircrafts. Your launcher should not made such a way that it cannot achieve the minimum speed itself. Okay, so that is the basic requirement. You should have more than that is fine, and but you cannot go minimum speed, like minimum than what is the minimum speed required for the aircraft. Okay, so that is there. Third is the transport vehicle to retrieve the aircraft. Sometimes they use like your transport vehicles are there running, and then maybe aircraft trying to land on that type of. Okay, so whole motion going to transfer to the your transport vehicles, correct? So it's fine. That depends on the testing how this work, correct? So most of the military aircrafts they are testing on the highway side because they are looking some way, correct, to land when runway is not there. And but here, like for the unmanned aircraft system, if nothing is there but moving platform is there, okay, so can your aircraft land on the moving platform? And let's aircraft is not moving further that already because transport is moving, so at least that motion can support, okay, for that. Or a little bit variations should be there because not sudden aircraft landed on the moving vehicle and stop there. Okay, so of course that is also required, so you should have continuous support like this. Then environmental conditions, this is the main factor, okay, because your deployment of the aircraft, okay, and we are going to deploy, this also matters. So ground stops, that's the one thing, means where are you going to deploy, not in terms of the your system, but in terms of the persons. Yeah, ground stops required to work there, correct? So where you putting GCS, ground controller stations, antenna, all should support, correct? Should support the minimum temperature, what the you're looking, and what the maximum temperature can support. Okay, so all the weather conditions, too much wind gust maybe should support. Then you have maybe the what is called I think somewhere uh, we are not sure about the actual bigger aircraft, but for a smaller aircraft it actually matters. When you see the soil property which has magnetism, correct? Many area, hilly area, you see the magnetism properties in soil itself. So many times sensor will fail, sensor is not working as per the design. Okay, so you should see all those conditions, environment conditions, if you rain or maybe you have day or night operations. Okay, what is the density variation in those area? Is it cold or is it hot? So it depends. All environmental conditions should be captured during the development of the aircraft. Okay, so you should have, okay, where your aircraft going to be deployed. Okay, so either you design a specific aircraft for a specific area, or you should have the common aircrafts which can support the various type of the area. Okay, because that most of the defense related applications, what they do, they procure, and before procurement they will test the models in different locations. Sometimes they will test the Rajasthan, sometimes they will test the China side, Uttarakhand, those area, Hyderabad, they will test first, and based on that feedback they will decide how this is going to work. And I'm not remembering the area where this failed because of the magnetic soil properties. So Netra failed, I think I remember. During the meeting I was there then. Netra failed because of the gyro sensors. Gyro sensor was affected, compass was affected because of the soil itself. And they was not getting what is the reason. Okay, they was thinking like, okay, sensor is getting problem or maybe system is not supporting. So maybe the sensor issues are there. Later they realized, oh, area is also problem. Like that complete area was different soil, and that soil has a magnetism property which was affecting the compass. Okay, so if magnetic field because of the environment is also affecting, then that you should check. Okay, that you should consider for the development of the aircrafts, especially when you're talking about the integration of the various subsystems or sensors on the board. So that is there, means different conditions they are talking about. That means all the systems, either electronics or the structure engines should not fail. And if you check the China side, especially near the border, at I think 12,000 feet height, they are finding difficulty in the engine side, means most of the fuel get freezes. Okay, so they need the heater. Okay, so at least fuel should not be freeze. Okay, so these are the basics requirement they will tell only when you are interacting with them, when you are interacting with the environment related scientist. Okay, then only you can come up with your actual designs. So many times engine will fail when you have different temperature, different pressure variations or density variations of the air. Okay, so you have to check all those environment conditions and how your either a structure going to fail, because of that they are not recommending complete 100% composite structure in those area. Okay, I think they are facing the problem, and they're supporting like they should have at least what is called wooden piece mix up with that, or maybe metallic materials mix up with that. Okay, to support this type of. So I'm not sure you can go ahead with the composite how going to fail when you have different materials. In the lab we are looking like when we keep and your composite is not perfectly made, then melting, I've seen that melting and falling down on the floor. So maybe possible. Okay, maybe that possible when I have different environment conditions. So that you have to check. You should look more points from the environment side, how affecting that. Extreme of heat, cold, all are coming. That may not support the sensors, communication equipment. Similar like a spacecraft, correct? When you are installing all the communication system or maybe all electronics in the spacecraft, mostly you will wrap with the gold foil, correct? 4 layers, 7 layers, 8 layers, not just for the EMI, EMC protection, but you're looking like a heat protection also. So you have seen that gold foil type of layer wrapped with all those things. And then I think you have seen they made the fuel related tank nearby that mostly. I think if you have seen the spacecraft structure, helium gas mostly they use for cooling that also. So depends, people are looking various type of the cooling systems is around the surrounding, and if possible, but aircraft how you will do that, correct? In the aircraft is not possible. So of course if your structure supports, then it's fine. The structures you can support internally, you can maintain the temperature for the electronics, or maybe you have to wrap the electronics in the different materials, let's that keep constant the temperature itself. Okay, so those factors should be considered during the all designs. So I think you read a little bit. Facility needed for night operation must be incorporated in the design of both aircraft and GCS. Okay, so that is there, and so you should have that facility. If you're looking in night operations, there is no payload. Okay, and if no payload, then how you will receive the signals, correct? Nothing, you can't receive anything. Only telemetry command is coming, which is the aircraft related, not your visual informations. Okay, so this is also important. The different day or night operations, you have different requirements, and that requirement should be incorporated in your designs, correct? Then atmospheric conditions, already we told what are the conditions require, you should design. Okay, and the altitude we are say like a altitude that possible, correct? Sometimes you're flying at the low altitude, sometimes high altitude. Okay, sometimes you have seen the passenger aircraft side turbulence, correct? Turbulence also coming in the picture. So of course any aircrafts when you're flying from low altitude to high altitude, what are the environment conditions going to change and how affecting that, correct? So if you're talking with the fixed wing, then fixed wing also should care during these things, like during the design. And if you're talking about the helicopter, of course you've seen the helicopters is not going very high altitude, correct? Maybe your blade is not supporting, or maybe your engine is not supporting. So depends. So that you have to consider. What is the maximum altitude provided for the helicopter, what is the maximum altitude provided for the fixed wing. Okay, so those variations are there, depends on the environment conditions, which supporting by the various components integrated with the aircrafts. So this is there, like if other important factors if you see that will be like what is called too high a level of acoustic noise. So normally what happened long back also this was the problem when a craft was flying, then too much noise was there. So you should not design their craft which has too much acoustic noise, correct? Because that will affect the persons who is staying nearby that or residential persons, correct? So military operation is fine. Military operation side they are not doing every day. They have a certain day or maybe month activities. Okay, depends on the need. Okay, but civil applications means you need every day, correct? If you're looking like a commercial purpose or civil operations purpose, then maybe you require every day. So your everyday requirement or deployment, how affecting the nearby the people or animals, correct? So those things should be get captured. Okay, those things should be care. If you're flying their crafts, then what are the acoustic uh, noise is generated by the systems? It can be from the structural vibration, it can be from the your engines, okay, like that, correct? So those things should be care. Uncontrolled radio frequency transmission, okay. So most of the time what happen when you don't have secure communications, or maybe your frequency is switching, correct? Maybe frequency is not controlled, then what happen, maybe that will be overlapping or interfering the other frequency. So other frequency channels, maybe some signals, radio signals are there, maybe TV signals are there, possible, correct? Different there is, maybe payload data are coming, different vendors are there, different organizations are working in this field. Okay, so different service providers are there. So what are the frequency going to affect the other systems, correct? That should not happen. So you should have very controlled type of radio frequency, and that is not affecting any other equipments. Okay, either in terms of the frequency, in terms of the power. Okay, that is also important. If your high power transmitted and that high power can damage the other equipment, the other service related receiver, then is not correct. That should not happen. This visual impact of either aircraft or ground-based equipment can be seen as spoiling the environment from the civilian point of view and can lead to vulnerability in military fields. Okay, so this should be also consider. Is it you're looking visual impact of aircrafts or maybe ground-based equipment? So many times, if you military type of the applications, they check like a GC should not be nearby the residential people, like residential area, and they should be very far away, like separate organizations campus will be there, GCS will be installed nearby that, and your aircrafts also not affecting the people, and normally camouflage term is also there when you want to hide the aircrafts in the air, correct? So depends how you're going to hide. Maybe you're talking about the different colors. You're talking about the light emanating. Okay, so you can make a light reflection such a way that becomes the invisible. Okay, so people are testing different type of things in military operations to great in infrared radar signature. Okay, so that also should be there. Means how you can use the different type of the payloads. Okay, sometimes maybe this can create a problem also sometimes, so that you have to take care how your infrared or radar regulated system going to affect the others, or what is the operations related specific. If that affect the system, then you should care that also. Okay, so design is also important when you are looking this type of the payload requirements or payload deployment, which may be confidential, which may be affecting the systems, affecting the peoples. Okay, I think just two more points I will escape this. Yeah, so maintenance point of view, if you check, because applications you will see for longer period, correct? So if you're looking like a longer period, then you have to see parallel, not only maintenance, I think service also. So maintenance, then services, training, all are coming in the picture. So if your system, your provider, or maybe your maybe the manufacturer of the components or product like this aircraft system, then at least you have three things in mind. You have maintenance, related, you have what is called training related, and then maybe services, correct? If you want, you are not going to give, but you have services. Okay, so you have enough thought before going designing this, correct? And so how long this can support, how many times you can support for maintenance, because like if you talk about this normal UAV, 200 maximum takeoff landing, correct? So 2 kg, 3 kg or 10 kg type of aircraft flying for 100 takeoff and 100 landings, or maybe 200 takeoff, 200 landings, means that is fine. This just is fine, means going more than that is not useful. Okay, so you can either discard that, or you can reuse the electronics for the other models, other structure models, correct? So that is should be either you're going to talk number of takeoff, number of landing, or you're going to talk about the time, correct? How long this can survive. Okay, lots of electronics will fail when you just keep. Okay, if you keep like laptops or smartphones for 2 years, 3 years without use, I think will be dead, correct? So that you have to see how long, how many times this can support. Okay, so not only just electronics related or a complete aircraft system related, but all component wise, battery also, all we are talking, correct, in terms of the applications and maintenance required, or replacing that, and then training the stops for the systems itself. So these are the factors which must be addressed during the initial design of the system, which involve the control of the system reliability to damage, system reliability, component lives, cost and supply, and time taken for component replacement and routine servicing. Okay, so these are very important points. Sometimes if you're developing the components and that components may not be there after longer period, correct? So that you should tell how long your system supports will be there, and how long going to take to repair that, correct? So replacement in terms of the your integration, in terms of your component availability in the future. Okay, so today maybe what is the system you have, after 10 years same system cannot get maintenance, correct? Or maybe you have different way, maybe this you have to replace the system itself or upgrade the system itself because you don't have options. So you should have this type of, because that many times most of the trainer aircrafts get grounded because for longer period, if you don't have the support, no maintenance, no service, and you don't have component itself, then you cannot go ahead, correct? Let's ground that, correct? Let's for the R&D applications and just a showcase like that. The achievement of adequate accessibility to the subsystem, both airborne and control station element of system, must be carefully considered in the initial design. May have significance in determining the configuration of those elements. So this suggests like you have to check all the component wise. Okay, so you should have adequate accessibility of some subsystem. Okay, either is it related to the aircraft or is it related to the ground controller stations. Okay, so most of the time what we do for a smaller craft, we procure, and something if you damage, we don't have access to get that, correct? So all those things, activities should do that. And I think that's the best example if you see the Tejas aircrafts, correct? I think why they started the Kaveri engine, correct? Because they was not, GE was not ready to give the engines for manufacturing and doing the business, correct? So sometimes like maybe manufacturer will give you the engines, but they will ask the maximum profit or benefits. Okay, because they know you cannot make the engine, you can make everything, but if engine is not there, how you will fly? Okay, so someone should be there and that will take advantage. So sometimes it's not possible, and if you are going again for your research, making your engines, of course will take time because those are established, and getting certification is not easy task. Okay, so you should check all when you have specific product designs. Okay, then how long you can access the systems, either through the procurement or maybe you're going to manufacture. Okay, so that is a very important point. This should be thought ahead of the your all this type of process. So system selection, we have already covered this HALE type MLE. Okay, and medium range tactical system, they may perform ISR type of applications, and this range supports around 500 kilometer. Close range systems normally supports around 100 kilometer. Then short range micro air vehicles or maybe nano air vehicles. So selections also depends on your this type of category, like classifications of the aircraft in terms of maximum takeoff weight or in terms of the range. Okay, how long this can fly and how much how long this can be in the air. Okay, so this depends to where either in terms of the your flying hours or in terms of your flying distance. Okay, so this is a very important point again when you are talking about the design. So which type of class of the aircrafts you want to manufacture, correct? So of course, if you're picking the particulates in this, so this is not required, correct? What is the need of all communications, then payload requirement like that? When we are talking about that, no need to talk about this much communication system. We're just talking about this much, a little bit more, correct? And if this payload is very small, correct? So of course, payload you can make it bigger. This is not a big thing here. This range never suggests aircraft cannot be very large, correct? Range suggests like, okay, you can have only 100 kilometer range, a radius of action. So that is the idea here, but aircraft can be a larger or smaller. Okay, that depends on the applications. If I have a 100 kilometer range requirement and I have 1000 kg type of payload requirement, so of course I should have maximum takeoff weight type of aircrafts available. Okay, which can fly 100 kilometer. So all the above can fly for these applications, correct? That is the meaning. So if you fly for this range, you cannot meet for this, but this can meet for this. Okay, that is the main important point. If you flying for this, of course this does not require. Why this? Because this is very high end type of aircrafts. This is very low end. So this is like just 3 hours means you're looking like a 5 kilometer, 10 kilometer, 30 kilometer like that. Okay, so this can be a simple way. And if you're looking like a more than 30 kilometer, then you can go ahead with this type of aircrafts. Okay, so 10 kilometers normal applications. Okay, and can go with the 10 kg, 25 kg type of aircrafts. I think this much was there. Just I will show you one or two models, then we'll just stop. So first I will show you one what is called let's fixed wing. Okay, I think aero student mostly they are knowing that, but we'll see. So if you start any like let's say 2 kg payload type of aircraft designs, or maybe have maximum 10 kg maximum takeoff weight, then we should have a requirement, correct? We start with some requirements. Okay, requirement during the requirements you already thought about some concept. What is the concept? Should it looks fixed thing? How looks that? What are the components should be there? Okay, so we are looking like conceptual as well as the preliminary designs. Okay, and then under the preliminary designs we are coming with the one of the models for R&D, not actual prototyping model which will be for production, correct? But actually for R&D purpose you can come up. So when you start, we start with the basics. You have some design requirements, you have at least sizing related, preliminary sizing, how looks that, then aerodynamic related. Okay, then stability point of view, like aircraft flight dynamics related. Then at the end you have test in fabrications, testing. Okay, so fabrication, integration, testing, like that. So when you start long back, maybe you're not talking too much the integration in terms of the electronics, correct? Just basics. You should have propulsion system, you should have what is called servos, few servos. Okay, you should have a receiver, that much. This much just basic electronics required on the board, correct? No autopilot, no sensor, other sensors required to control the aircrafts. So basically you are controlling the aircraft. So fabrication is important when we are talking about the R&D, and in the future slowly they are looking like electronics how becomes the important in terms of the autonomous activities or stability of the aircrafts. Okay, so we will see that when we start, at least basics few should have. So already you have seen the selections, correct? Selection criteria, you can check all the 8 or 9 points or 10 points, and let's you make your requirements. Okay, then someone will give you, let's you make your requirements by looking 10 selection points, and every selection points you can fix the values, correct? Some quantity, some numbers you can fix. So when I started with this, there was target maximum takeoff weight, let's 10 kg, or you can go ahead with the little bit less also, 7 kg to 10 kg. So 2 kg payload. Okay, you cannot achieve any air like a design 2 kg for maybe 4 kg or 5 kg type of aircraft, maximum takeoff weight type of aircrafts. Okay, you should have at least minimum 7 kg maximum takeoff weight, then only you can come up with the 2 kg. But you have to compromise with the endurance. That is also important. Okay, so payload as well as the endurance, this matters, because sometimes your propulsion system going to take this weight, okay, to support this. So if you have endurance, already endurance is there, and you are supporting like for longer endurance, but you can manage the payload. Let's have lesser payload, so you can accommodate the battery here. Okay, in terms of the payload, you can put extra battery, but you can manage here little bit less, but you can't manage. Let's your payload is actually 2 kg, so you cannot give any option here. So this will be 2 kg. Okay, means what the battery available that time, means what the maximum takeoff weight will be their parts, structure weight, especially electric we are talking, structure weight, then electronics, propulsion systems, then you have what is called payloads. Okay, those things, correct? If engine, then engine plus the fuel we are talking, plus the structures, plus the payload. Minimum, this is the minimum electronics. So this is the minimum, means if you add all the weight, then what is the maximum takeoff weight that aircraft can take. So design is important, means what is the maximum lift can be generated, okay, to support the weight of the aircrafts, maximum takeoff weight of the aircrafts. Because that people are talking, if you can generate the little bit higher lift, okay, if higher lift, which can be used for the gliding, correct? Because you have to cut down the engine sometimes or motor sometimes, and let's say that aircraft can glide. Okay, so at least you have a backup, or like you, at least you can save the battery, or you can save the fuels for a few minutes at least. Okay, which will be converted in terms of the endurance at the end, correct? So like you are improving the endurance, so you should have good design in the wing side, where at least can support the glider also, correct? Gliding activities. If you are making very constant your maximum takeoff weight, somehow going to manage with the lift generation, like what is the wing size you have designed. So I think that is not acceptable. That's not going to support the gliding options, correct? So that you have to take care. And so what is the design you are talking, and how that's going to support for longer period. Okay, then total aircraft weight means you have 2 kg this, and then if total aircraft weight assumed 6.5 kg including this 2 kg. Okay, means structural as well as your electronics, battery, plus your payload. Okay, so we are talking about around 6.5 kg or 7 kg type of the aircrafts. Okay, based on that your wing size will be around 1.5 feet, or maybe at least, sorry, 1.5 meter or maybe 2 meter itself. Okay, if less than 2 meter will be tough. Okay, 1.5, yeah, maybe 1.2 meter approx can support 3 kg, 3 kg, 4 kg around, not more than 300, 400 gram payload. So you have to check what is the maximum wing sizing can be there. Okay, is it chord and your wing span both has considered for wing span area or not. Okay, so you have to check all those activities, because at the end we are talking about the surface area of the wing, correct? So that will give you the what is the lift required, half rho v square s into cl, correct? So s is important here. We'll see, especially this design. So you have some requirement, then some sizing they have done, preliminary sizing. Let's chord of being something varying between this angle of attack they are expecting, because they have non activities. Okay, this type of aircraft mostly flying this type of angle of attack, then fine, good. Okay, it's not required too much like knowledge to put there and analyze, then come up with, okay, this particular angle of attack only going to work. So based on the previous knowledge or previous pilot rating of the aircrafts, you can go ahead with the considering the what is the actual normal preliminary sizing you require, correct, for angle of attack or record of being working angle of attack, then stall angle of attack. You should check all those points with the designs also, but you should have some idea then what the wing area B into C we are talking here. Okay, so then Reynolds number is also important, because if you're looking like a velocity, what velocity you're talking and what are the Reynolds number will supports. Okay, so that you have to check which type of aircrafts, what are the velocity supports, so that designs comes under particular Reynolds number or not. Okay, so I think this is the aircraft design side, you have to clear this. Then previous class I saw on you a few link where you can get their file data, because someone already has done lots of experimental tests and they have already uploaded the data, so no need to go ahead further similar type of series, correct. So you can take those series and then you pick up as per your requirement, what should be the wing span, what should be the chord. Okay, so you can go ahead with the particular files. Okay, and then if you have selected the particular files, then at least you can analyze all the C, CL, or maybe the CL versus CD, all that those things, correct. Then CL versus angle of attack. So this is the idea, means all the parameters should get analyzed first. So this is the important point, means you should analyze at particular Reynolds number what is the your files you have selected. Okay, and what are the response of that. Okay, so you have to check how much drag coefficient are there, what are the lift coefficients are there. I think this is exciting one, depends which airfoil you have selected at a particular angle of attack, and after maybe higher angle of attack, this may be going to stall that, correct. So lift coefficient going to be um, decreasing after certain angle of attack. Okay, so this is Clark Y used for this. Okay, and once you have that data from the website, or then you can generate check. Okay, and you can decide this looks like Clark B, and then Epler 387C. So you can get what the chord we are talking. Okay, so this is like a vertical cross section of the wing. So this is their file, already you have seen the nomenclature, correct. Leading edge, trailing, then mostly will be this chord line starting from leading to trailing, and camber line mostly will be the locus point, correct. You take the mid of these everywhere and just you connect. So you will see the locus of the midpoint of these two surfaces, like upper and lower surfaces. That is the cambered line, correct. So somewhere you will get symmetric, somewhere unsymmetric type of. There is a cambered, sometimes cambered, more cambered. Okay, so it depends how you're going to, is it fixed cambered or maybe you have flap type of the applications to you make more cambered there. Okay, so airfoil shape analysis is also important. How looks that? Okay, what is the CL you got from the particular this. Okay, and then which speed you made, Reynolds numbers. Okay, wing span area, you have to take all for the analysis. So this is just variations, aspect ratio, and your span, wing span area variations. This is around 2 meter, approx 2 meter, which can chord this. Then you will see the V curve for thrust required. Okay, so if you're looking like this particular speed, so 5 to 15 you have like a not good achievement. Okay, so thrust required going to vary. Maybe initial period when it starts, maybe the behavior is not same, correct. Behavior can be different. So let's, you should have what is the speed you are looking, so what is the thrust required. Okay, so that way you can think. But 70% we talk, at least you have 70% thrust. Okay, if you're like 10 kg aircraft you want to take up, so at least 6 kg or 7 kg thrust you can get from the propulsion system, either electric or engine. Okay, so you have to look that if you have very high thrust available, high thrust propulsion system available, that is fine, that can take care, that can like a drag that, correct? But is it supporting for the flying or not? Okay, so you should have at least analysis over this also. What is the minimum thrust required to support for just making the minimum speed of the aircrafts? Okay, maximum is fine, but maximum is not go very high, because every aircraft's structural properties also can create a problem, correct? Because if you have too much thrust and let's structure is not supporting, then what is the need of that? So mostly in the balsa, if you're talking about the smaller UAV designs, then balsa cannot support for high maximum takeoff weight type of the designs, and you cannot go ahead with the very high end type of the propulsion system also, because maybe that vibrations not supporting the structure, correct? So you have to check all those basics designs, and this is the idea, like a power available, power requirement at the speed. If you constant, then it's fine, but this is a power requirement, okay? And this is the like maximum power available from the aircrafts, yeah, maybe the propulsion system. So at this speed, this talks like till 40 meter per second. If you are talking, then it's fine. This can support. This is the required speed to achieve. So already have power available. But when we talk about more than 40 to 45 or 50 meter per second speed, then this power is not capable to provide that. That is the meaning here. So if you check all those analysis, means you have to test the propulsion systems on the ground, what the maximum current voltage can take, what the RPM going to give, and what the maximum thrust will be available at different throttle variation or maybe power variations, correct? So that should be analyzed. Maybe at a different speed, you require different throttle requirements or maybe the power requirements, correct, for thrust. Okay, so that should be analyzed. Okay, that should be analyzed, and maybe that going to based on your motions, of course your drag also going to affect. So how speed, if you higher the speed, how drag going to be increased? Okay, so that should be analyzed. Should we analyze? So what are the recommended speed should we capture by looking all the parameters? This is just CL/CD variations with respect to the speed. Okay, so CL versus CD is good here at around 20, so 15 to 25 meter per second is good. But if you're going down, means this is not good options, because CD may be going to increase because of the speed, and when a speed is also less, this is also not good, because maybe the CD is more. Okay, so you have to justify after the analysis what is the CL versus CD we are talking. Means this should be larger, correct? CL always should be larger than CD. So what is the speed recommended for the aircraft design is important here. Okay, rate of climb is, if sometimes very fast, sometimes very slow. So what is the rate of climb going to support the aircrafts, either in for the structure or for the your what is called sensors, electronics itself? Okay, it also should be analyzed. Okay, so if you're looking like a rate, this not like a fix, correct? This can be different for different aircrafts. So we are coming in the future for actual aircrafts, like especially HLE type or MLE type, we have flight envelope type of analysis. So I will show you the various types of the diagrams where we are going to analyze all these factors there. Okay, so this is just for the one of the smaller UAV system. So just analyzing. Okay, so you have different flight envelope parameter analysis. You can calculate the endurance, you can calculate the range based on the formula. Okay, so I'm not going details. Then I think this is just mathematical models used for calculating all the points, and fabrications I think someone already has done. If not done, then since bulk supply, yeah, for a smaller composites, getting correct, aluminiums, aerospace, like 7,000 series, more than 6.5 or 6, at least 6,000 series, more than 6,000 series aluminum, you will get the good quality. So you should have lightweight materials but good strength, correct? That is important. We should not have high weight and not good strength, correct? So this is important that you have to take care for the manufacturing. Then engines, it is also means how much engine supports. So all components, okay, you have to analyze the all components required so subsystem wise. So this is just one designed during our courses. So I am not saying now what we are doing. So this is one, I think another one model tested in the wind tunnel. So I will tell you this. So when you are going to conceptual design, then there was a question, if possible, you can go with the mock-up models, correct? Either using the wooden piece or maybe the soil, yeah, gypsum related. Today people have a money, a finance, so at least they're going with the composite or some other materials, okay. But of course, this is one of the requirement when you go for the designing the aircrafts. You should have at least experimental data available, not just CFD data, correct? CFD is fine, theoretical analysis you can do. You can design very advanced models, optimized, designed. Then you can do the CFD analysis or flow analysis like aerodynamics analysis. So you have, of course, good designs. Then you again you can go with the FEM structural analysis. Means if you pick up the materials, then you have idea what are the pressures can hold, what are the various these structural variations will be there in terms of the pressures or in terms of the strength, correct? So different materials at different locations you can change, but the idea is there, that is the software analysis. What about the actual, when we are talking, when we manufacture the hardware, we should go further, either in terms of the structural testing or in terms of the your aerodynamic testing, correct? So aerodynamic testing is one of the your wind tunnel. So you should have model, okay. In the wind tunnel models, you should have a sensors first, and it should check what is the maximum what is called cross section of the wind tunnel, correct? So this is 9 by 14 feet. So 9 feet height and 14 feet. This means you can go ahead with around 12 feet this much, and at least 8.5 or something. 9 feet you can't go, correct? That will hit the this wind tunnel itself. So you should have clearance, like air should pass, not just like hitting this and going. Okay, so you should have clearance from all directions. That is one thing. And so you put the aircraft which should be as per the cross section area of the test cross section area of the wind tunnel. Okay, and I was there during when Bombardier aircraft tested. I think that is the similar type of aircraft, 10 feet aircraft design, and all being was with the pressure sensors imported integrated inside, just like a wing was 24 lakhs cost. Okay, so when you see, then that is one requirement. Then you should have wind, what are the speed you require. So you should have something fans, correct, which will give you the particular wind speed, so that will drag. Okay, so particular speed will be coming. So that is the one thing. Then there are meshing, like mesh inlet side, which will make a smooth air. Okay, every section of the every point of this test section should have the same velocity. Okay, that's the environmental conditions we are talking now. Then many static system will be integrated in the wind tunnel to monitor the your air speed at different locations. Then you will see the density also to measure. Some sensors will be there. Okay, so temperature sensors, then pressure variations, lots of sensors will be integrated to monitor what is the wind tunnel environment itself. Then comes, you should have a model, one model, and model load. Model load is very important. So you should have load cell, which is called 6 component strain gauge balance, correct? So you should have load sensor, load sensors. Load sensor is actually inside here. So once you have like a setup, then sensors are inside, and sensor will be like a mostly a strain gauge sensor. Okay, which will be connected through the electrical wire. Okay, electrical wire, and this will be available in the computer side to get that voltage. Okay, so all the sensors will give you voltage data, and that voltage data further will be converted in terms of the G or maybe pressure. Okay, based on the further mathematical model, you will get CL, CD. So I will show you what are the parameters, what type of data generated from this. So there's the one thing, and this is the static. But what you can do, these systems can go inside. Okay, so this can change. So what this happened, this will make the angle of attack. Okay, so if your wind direction is not changing, wind direction will be in the same, only you are orienting the direction of the aircraft. Okay, nose direction of the aircrafts. So this becomes the some reference, like your reference wind, what is the wind direction is the same, but your this direction changes. So that is called angle of attack there. And other thing what they can do the yaw also. So mostly they are looking the side slip as well as the yaw angle. So they can change here. So like you have angle. Okay, not just angle of attack, but side slip also can get. Yeah, angle at least you will get. Roll facility is not there. If you want roll, then you should have another setup here which rotates. Okay, means you can rotate your models. So normally what is the requirement there? You should have load cell like a strain gauge balance sensors. Okay, which require based on your weight of the aircrafts. Okay, if you want to test, let's 3 kg, you cannot use the 10 kg or 50 kg type of sensors. Okay, so you should go with the let's 3 kg or 5 kg type of sensors are there, means maximum can test 5 kg. And if you want, let's 50 maybe 10 kg or 20 kg type of aircraft should be tested, then at least we have 10 to 50 kg type of sensors, means that the threshold load sensors require. So that is the meaning. We cannot use 50 kg type of load sensor to test the 2 kg type of aircrafts. Okay, you will get a wrong data. So that is the important when you are testing inside the wind tunnel. And then this was a very complex activity. This was one of my project during the ISC, and this is the first time tested in the wind tunnel in the ISC. Long back only through blade was tested. That was the static. Okay, so this was like you can tell like in ISC first time. So all professor was worried about that what going to happen with the wind tunnels when you're testing inside. Okay, and this was running conditions. Previously never happened running condition inside the bindle. So I will show you this, and then I will show you the data today. Just just one test first. What we do before testing the models. Okay, so if you are testing the model, what is the basic requirement during the conceptual designs or preliminary designs? Means you should not test the model, you should test the setup first. Okay, so you will get the setup test related CL/CD all variations, because this is going to be added with your aircrafts. Okay, so any weight or any setup what you put, okay, all weight acting on the sensors. So those sensors data going to be considered during your actual test. So this is a very important point. Most of the people they will forget, but when you do this type of activity, let's you have at least test setup test data, and that going to subtract from the actual test data. So this was tested a static wind without a wind, then with the wind. Okay, so I think you are seeing correct. So then we have tested a little variation also. Otherwise normally need at least at zero angle of attack. Okay, so zero angle of attack you can test this. And all data is loading in the computer side. Then after once you have tested this, then you will get tested this type of. So like too much acoustic, too much sound was there, that there was worry about all this, like what are the problems are coming with the testing of this. So we supposed to write the all failure cases also. If anything fails inside, every person was worried, because when you see this actual test inside the wind tunnel, pilot has given the complete throttle. Okay, so aircraft was supposed to take off, but the system was holding. Okay, and because that this system failed inside, complete swash plate mechanism got like damaged. So free engine was not operating the blade itself, like auto rotation you are knowing, correct? So this happened inside the wind tunnel, and no one was knowing what happened. Then again realized, because you have given the full throttle, so aircraft supposed to take off, correct? But this system was not permitting to take off that. Okay, so these are things. And data, what you will see, I think just I will show you the data. Mostly you will get data like this. Okay, so we start with all the parameters which required. You should have a wind speed, time, those things will get captured. Okay, and is it wind on, wind off conditions? If wind off means you should not run the fan, correct? Instead the static, yeah, with the what is called 3 meter per second wind normally will be there, correct? So we are capturing that. But when you given the, yeah, if your fan is rotating, then what is the speed you reached, correct? So 12 meter per second if there inside the wind tunnel, then that velocity will be considered relative velocity of the aircrafts. Okay, then you should have being a span area, then reference, okay, chord. So mostly we are looking from the nose. Okay, all those points, these are the points required. Fuselage, nose, then from the fuselage reference line, from the balance center, like where you put the sensors, all those before like setting of your system. Because if you're not giving this data, you can't get this data. Okay, so all these data require, so you should have proper calculated. Okay, you should have spent time for looking all these parameter again, because you're testing, one test costs 50,000. Okay, if you're flying just like testing for 1 hour, they will charge huge. Okay, our project was there, so there is no question about that, correct? But if you're talking about the 100 test or 1,000 test like Tejas aircrafts, then you, of course you should pay for that. So what is this? This is the zero angle of attack, tested for zero angle of attack. Okay, this is the velocity, this is dynamic pressure inside the wind tunnel, and then this is the body axis related. Okay, so you have the z direction, in the x direction, in the lateral direction, then pitching moment, rolling moment, and then yawing moment. These are the coefficient in the body axis. This is the wind axis, like lift coefficient, drag coefficient, then lateral coefficients, then pitching moment, rolling moment, yawing coefficients. Okay, so all data you will get calculated, and then further you can go ahead with the analysis, like a CL versus alpha, we can do that. So if you check the another parameter, I think then you will get the idea. What is that? Yes. Different data. Yeah, this test tested at different angle of attack. Started with the -6, -4, -2, 0, 2, 4, 6, 4, like that, continuous. We are looking his stresses. Okay, you should not stop like one test. You should go back again. Otherwise, you can't get his stresses loop. Very important point, because sensors, what they will do, they will capture the previous data also. So there are lots of analysis during the testing itself. Means is it when you stop your sensor and started again, is it the same sensor data, or is it previous data recorded there or not? Okay, so we have to do the various test with the different angle of attack, different wind speed. Okay, so and if you are looking like a different side slip also, then you have to do that. Okay, so I think side slip we have not captured, already failed after I think 6 or 7 tests inside the wind tunnel. Then we have stopped that. Okay, because we have tested the off condition, we have tested the helicopter on conditions. Okay, and during the on conditions, one first time itself failed. Okay, off condition we tested, on conditions he has given the full throttle, because that this problem has started. So we have to stop that, correct? So there was worry about that. Means maybe load sensor will fail, strain gauge balance sensor will fail. So lots of factors comes when you have vibration type of systems testing inside of the wind tunnel. Yeah, so I think this much was there related to your conceptual design when you're talking about the internal testing and flight testing. If you talk similar way, like aircraft also you can place. This is the helicopter, so we talk the helicopter. And other way you have flight test data. So start with the flight test data. I'm not showing the video now. You can go through the YouTube's. Is there? Okay. So tested with the various maneuvering phases, like I think if I want, let's see. So they do the like what the different. So same way, like you can go ahead with the fixed wing type of the models. I think hanging now. Yeah. So just see one model. Just like the full roll, full pitch, full like a inverted every like, this inverted. So just I given these two tutorials to just make sure that you have at least a basic idea when we are talking about the conceptual designs, the preliminary designs, then what are the at least basic steps should we follow? Okay. And of course, if you talk about the bigger aircraft also, we cannot go with all this type of test facility. So we have to scale down the aircrafts, and after scaling up, only we can do that. Okay, so Reynolds number and Mach number is important. Every time you should follow that. Only these two factors are there. Yeah, these two terms are there, which will give you options to convert this data, like a scale model data, to the your 1:1 scale model. Okay, so that there. And you can search. I think if you Windtunnel only has facility where complete aircraft can be tested. Mostly NASA side you can check if possible. Okay, but in India, this type of facility is not there, and only a scale model you can test unless you have conversion of those data for the actual models. Today we will stop. If you have any doubt, then you can ask. We will stop today.